Our sample problem. A proton is fired into an E field as shown. Which plate does the proton hit and where does it hit the plate? I'm going to first decide what the path of the proton looks like. So it's positive, it's fired in this way. I'm going to look at the direction of the electric field. By knowing the direction of the electric field is up, I know that this is the positive plate and that's the negative plate. Since I know that that's the negative plate, I know that's the one the proton will be attracted to, and it's going to follow a path like so. When I say where does it hit, I want to know what this distance is. I'm going to take an approach similar to projectile motion, where I'm going to separate my motion into x and y motion. I know the x velocity to be 3 times 10 to the 5th meters per second. The x displacement is exactly what I'm looking for this problem. For the y, initially it's only moving in the x direction, so we use a v initial y of 0. My y displacement is going to be half of these 12 centimeters, which is 6 centimeters, but I need to convert that to meters, 0.06 meters. If I have the acceleration, I can then get the time. If I can get the time, I know the time for the y direction also. For these problems, we're always going to get acceleration using EQ equals ma. E is 10,000. Q is the charge of a proton, which you should already have in your notes as 1.6 times 10 to the negative 19th. Equals the mass of a proton, which is also in your notes, times acceleration. 10,000 times 1.6 times 10 to the negative 19th divided by 1.67 times 10 to the negative 27th gives us a huge acceleration of 9.6 times 10 to the 11th meters per second squared. I'm going to carry that value over here. Now I can solve for time. The kinematics equation I'm choosing to use here, d equals 1/2 at squared plus VOT. Since velocity initial is 0, it becomes just this. 0.06 equals 1/2, 9.6 times 10 to the 11th, t squared. Solving for time, we get a really fast 3.54 times 10 to the negative 7 seconds. This particle's moving really quickly and it's not going to go far. A really short time is logical. Okay, the last thing I need to do to find x distance is to use x velocity and the time. Distance equals rate times time, giving me displacement of 0.106 meters or 10.6 centimeters. That gives me my answer to the problem. You will also see problems where I tell you where it lands and I want you to find the initial velocity, or I tell you where it lands and the initial velocity and I want you to find the E field. You will see both of those types in your homework and on a review.